Hello, welcome to this new unit on complex numbers. In this unit, we are going to try to define what is the product of complex numbers, and we are going to see some properties and examples. The requirements that are required is simply to know what a complex number is, and to know how to operate with real numbers. There are no extra requirements. Well, let's do first a little review of what we saw last unit. A complex number is of the form of a plus b I. It is said to be in binomial form in this case, where a and b are real numbers, and the number I, the so-called imaginary number, is equal to the root of -1, or what is the same. You can say that I squared is equal to -1. Also, let me remind you that in a complex number of binomial form, a plus bi, a is what we call the real part of z, and b is the imaginary part of z. Well, suppose we have two complex numbers, a plus b, I, and c plus b, I. The product is defined as follows: a plus b, I, c plus b, I equals a, c minus b, d plus a, d plus b, c. Well, this, although at the beginning it can seem a little complicated, actually later we will see that it is easier to do it in another way and not to learn this formula. Notice that, let me remind you for a moment, the first part, the real part of this product, is simply the product of the real parts and the imaginary parts, with a change of sign in the last ones. And the imaginary part of this complex number is simply crossing the numbers. The real part of the first one with the imaginary part of the second one, the imaginary part of the second one with the real part of the first one. Well, what properties does the product of complex numbers verify? To begin with, the commutative, that is, the order of multiplication, does not affect the result. The associative, if we have to multiply three complex numbers, it does not matter where we start multiplying. There is also the neutral element. In this case, it is the 1 plus 0 I. This number will be used later to define the inverse of a complex number. Every complex number that is different from 0 plus 0i has an inverse and verifies the property that we see here next. Z times z minus 1 is equal to z minus 1 times z, which is equal to 1, or to the neutral number 1 plus 0i. Well, let's leave up here on the transparency the definition of product, and let's look at some example. Let's imagine that we want to multiply 3 minus 2i by 1 plus 4i. If we apply the formula as it is up there in the transparency, what we would have to do is this product. Notice that first we multiply the real parts of the two complex numbers and put it in this place, 3 times 1. Then we multiply the imaginary parts of the two complex numbers and we put them here. Change sign, notice. Then the crossed products and the imaginary part of the product will follow. 3 times 4 we put it here, and minus 2 times 1 we put it here. All, of course, with the number I. Then it is simply a matter of solving these calculations, which are quite simple, as you can see, and simplifying. The final result is 11 plus 10i. Do we need to learn the formula for complex numbers? No. Actually, what we can do is simply multiply exactly as we have multiplied the real numbers. Keeping in mind one small detail: when I squared appears, remember that this is equal to -1. If we multiply, we are going to apply the distributive property of the product with respect to the sum. First, we multiply 3 times 1, which gives us 3. Then, the same number in the real part of the first with the imaginary part of the second, 3 times 4i. And we put it still without simplifying, so you can see exactly how the process works. Next, minus 2i times 1. That is, it is the imaginary part of the first times the real part of the second, and finally, the imaginary part of the first times the imaginary part of the last. Now, it is a matter of simplifying and arranging each term separately. Notice. 3 times 1 is 3, 3 times 4 is 12, minus 2 times 1 would be minus 2, and minus 2 times 4 would be minus 8, and I times I, notice that would be I squared. Here is the term. This one you have to keep in mind now is minus 1, so it would change the sign of that minus 8 term, as you can see below. Now we would simply join the real part with the real part and the imaginary part with the imaginary part, taking out the common factor of I, notice, 3 plus 8 plus 12 minus 2 times, I. The same result as before, 11 plus 10i. Well, what have we seen in this unit? We have seen how the product of complex numbers is defined, that we have the formula or simply multiply, as we have done so far, in the real numbers, taking into account that I squared is equal to -1, and the properties that are the usual ones, the ones that we can find in the real numbers, rational numbers, and so on. So much for today's unit. Thank you.